MTech in Computer Science from JNTU College of Engineering, Anantapur, and Bachelor of Engineering in Computer Science and Engineering from Gulbarga University. She is currently guiding 4 PG student projects and 5 PhD scholars as supervisor and 4 PhD scholars as co-supervisors in collaborative research. In the past decade, she guided around 40 PG projects and 30 UG projects. She has attended 10 national conferences, 35 international conferences, published papers in national journal and 25 international journals. She has also presented papers in international conferences at University Kuala Lumpur, Rome and Dubai. Supriti ma'am is the co-principal investigator for UGC major research project on design, construction and analysis of comprehensive dataset for emotion detection using multiple biometrics. I take this opportunity to invite Dr. Supriti Madam to start the session on Introduction to Big Data based on IoT.
Supriti ma'am. Supriti ma'am.
Supriti ma'am.
Supriti ma'am. Namrata ma'am, I'll call ma'am and I'll check and I'll get back.
Yeah.
Dear participants, please wait for few minutes. We are solving the issue. Dear participants, please wait. Dr. Supriti ma'am will be with us in short time.
Participants, please wait. I will let you know.
Hello. Kavita madam, am I audible to you?
Yes, ma'am.
Okay.
So 1 minute, madam, I'll share it. I'll share my screen.
Okay, ma'am.
Right. Sorry for the inconvenience. So
Never
good
mind,
afternoon.
ma'am.
Okay. Actually, I had some problem with technical problem. Okay. So I will start. So can you just, Kavita madam, you have given my introduction to the participants. Can you just brief me about the participants, like how many members are there? I could see around 40 plus.
Ma'am, we have got 187 registrations for this FDP,
Okay.
and
Very,
like nearly 100 are active participants, ma'am.
okay. So right now we are having around 45 members.
Yeah, ma'am.
Okay. Okay. And
66. Yeah,
okay,
66 attendees are there, ma'am. Yeah.
okay.
Yeah.
Okay. So just I just want to know, like all of them are from computer science and engineering and IT.
No, ma'am, we have from different streams also, like
Uh,
researchers so from IT
yes.
or from different streams, ma'am.
Okay. No, I just want to know the audience. Like I cannot make some assumptions and I cannot go forward. So can I expect that they'll have a little bit of database management systems knowledge, data analytics knowledge? Can I assume it in that way?
Yeah, ma'am. Yeah,
Okay.
like uh, all
Okay.
are from like background is from IT itself, ma'am.
Okay. Uh, Maximum computer science and engineering and IT. Okay. So
Yeah, ma'am.
today my session I'll be focusing. Okay. Good afternoon, all the participants, and I appreciate all of you for joining this FDP. And I wish this FDP will be giving you a lot of knowledge, and it will also set you directions for your research career also. Okay. So in today's session, so I'll be focusing on big data. So some of you may be interacting, or some of you might have knowledge about data science, because the AFDP title is also about uh, uh, data science and deep learning. Okay. So let me just can I have interaction with the participants? Anybody? So no, Kavita madam. So can they talk to me?
Yeah, yeah, ma'am. They can talk. Like they can
Okay.
unmute and they can talk.
Okay. So can I hear from you, because I have also attended a lot of online workshops and FDPs, and many number of times it's happens. It's one way. So I just want to see that I have little bit interaction, at least few participants. Okay.
Yeah.
So so can I get, or can I just listen from somebody, like what you know, or what do you mean by big data? Nobody?
It's a huge collection of the data organized in some systematic manner.
Okay.
Lots of information. Collection of information.
Yes. Yes. Okay. It's collection of information. It's
Like through
different.
IoT devices, they are sensing and they are sending off so much of the data regarding
Okay.
of whatever, wherever we kept it of the devices there. It
Yes.
sends the data. So the big data is nothing but we have to analyze the data and we have to process and send it out what actually the output must be required.
Okay.
After getting that, we have to analyze the data. That is nothing but big data.
Okay.
Okay.
So good. Thank you for the response. And are you able to see the screen now? Kavita madam, just assure me. Are you able to see in my PPT?
Yes.
Yes, yes, ma'am.
Okay. So we usually have okay, I'll run it in this way. This is big data. So as some of you have mentioned, it's obviously large volumes of data. And when we discuss about data, and I want to make because I've been teaching database management system for 2 decades. So just I want to give you one little bit clarification. So let's not mix the words data and information. So data is considered to be raw facts what we collect from the real world. When we process data, we get information. So in this particular session, we only focus about data and processing it. So big data means we are collecting large volumes of data from the real world. As you know, you already have the introduction about IoT. We collect from different devices. You collect from human beings. You collect from sensors, smart devices, mobiles. Various ways we collect the data. And as you see, it has gained a lot of significance because of the advent in processing powers as well as a lot of comfort in using internet. So especially when you see you have smart devices in your hand and we keep on generating data. So again, when you discuss, so you can see, so if you take a normal young person, definitely they'll take 1 or 2 selfies in every day. That means earlier, 15 years back or 10 years back, when we don't have the smartphones, so taking a picture, that is generating an image, was very complicated. But now you can see you have a lot of scope for data generation. This is digitizing the images, digitizing the videos, everything. So with this particular advancements in internet usage, in processing power and everything, so people have started moving towards using data. That is, we are considering it as big data. So that is very, very large volumes of data. So just to mention you about the capacity units. So as all of you are from computer science background or IT background, I don't want to take much time, but just I want to just mention you. So we have the storage capacity units in bytes, that is kilobytes, megabytes, gigabytes, terabytes. So last decade, we were only focusing about till terabytes. So we, when we tell that I am having my hard disk 500 terabytes, so it was more than sufficient for us. And when we were discussing 2 decades back, when we were discussing about databases, so there you can see we were always focusing database will be stored in secondary storage. But now if you see, we are having, let us consider 64-bit processors. Okay. So I'll just give you a question and you just quickly tell me. If I'm having a 64-bit processor, so how, and I'm having byte addressing storage capacity, the main memory, let us consider. So how many bytes of memory I can address comfortably? What is the maximum size of the memory I can address with 64 processor? Is my question clear?
I can able to address over 64-bit storage information.
Yes,
I can.
it's correct. So can you convert it and tell me with respect to this nomenclature or the taxonomy? Kilo, mega, giga, tera, peta. So just
2 power 30 itself tera.
yes. So just you see the second bullet. So I'm very happy we have very active participants, and all others also. Please be involved in the lecture. So you just see the second bullet, that is 10 to the power of 3 is kilo. That is equal to 2 to the power of 10. So like this, when you see uh, kilo is that, and iota, the last storage unit is iota, that I'm having it as 10 to the power of 24. So here if you see, kilo is 10 to the power of 3, mega 10 to the power of 6, giga 10 to the power of 9, and tera is 10 to the power of 12, peta is 10 to the power of 15. And when I go with exa, okay, so it almost comes to, so 10 to the power of. So like now when I have to take with 2 to the power of, so it's 10, 20, 30, 40, 50, 60. So exa itself takes to the power of 60 bytes, exabytes. Okay. And if main memory itself, like when I tell 2 to the power of 64, you can split it into 2 to the power of 60 into 2 to the power of 4, that is 60 exabytes. Your main memory itself, like if I take 64-bit processor and if I want to have so much RAM chips, I can accommodate so 16 exabytes of data in my main memory. Forget about hard disk. So this is actually the storage capacity what our systems can have. Because of this facility, so obviously we can comfortably think about big data. So earlier when we were dealing with VMS, we were telling file systems have that disadvantage. We can go for storing in secondary storage. But now we have actually the concept of in-memory databases. I hope some of you might have heard about this. So when we deal with big data, so the storage facility what we are having right now with our systems is allowing us to handle big data. And that is also not less. So you can see the last 1 decade, the people have become active contributors, especially with the advent of web applications, mobile applications, social media applications. And when you deal with any mobile app, you are purchasing something, they ask you to give feedback. That is, you give reviews, you give some your feedback to them. That also contributes to the data. Like this, data keeps on increasing. And with this particular comfort zone, people started thinking about lot of big data applications. And here, because you people have already discussed about IoT in the thing, so you can just think, so all the applications, whatever we have for big data, almost the same applications we also have the usage of IoT devices. So here you can just see, so healthcare, travel, education, telecom, e-commerce, media and entertainment, retail, finance, so a lot of things we have. And big data has a lot of features also. I'll just explain you. So before going to all that, so I was actually very much interested in media. Like I want to give you an example of media and entertainment. So have you been discussed about media and entertainment application in the earlier sessions?
No, ma'am.
Can anybody guess what sort of application they want for media and entertainment?
So depending on the reviews, actually we can categorize, we can give the ranking of how good actually the product.
Okay.
Because
Now,
advertisement. So that.
Okay. So yes, media and entertainment, I can give you about electronic media, the news channels. Okay. So the TRP ratings, all that comes under this. And one more important thing is they have a huge collections of videos with them, and they want to pick the relevant video from the existing videos. Now let us consider they want to focus about some politician, or they want to focus about a movie artist. So they should have some application. So the application should be in such a way that it will look into the collection of video database, and it should immediately pick up the relevant. Like let us consider a famous politician expired. So on that particular situation, he might have given a lot of interviews to them, or he might have participated in some other event. They have that video database with them, and using this big data applications, it has to dig deep into the video and it has to extract exactly the bit. So where that particular person is projected. Like this, we have actually a lot of applications where you require big data processing. and exclusively one particular situation, the program should make a decision and it has to project something. Like, let us consider something good. The video should show something good about that politician. Your program should pick up such kind of thing. Like this, again, we'll have the sentiment analysis also there. So like this, we have lots of applications. So education, now you see, because of this pandemic, all of us are very much comfortable with these online classes. So like, you need not travel, or you can continue with your work, and parallelly also we can handle the things, and like this when you see. So in education also we have a very huge data generation, and you can see about the videos and graphics and the teaching material, whatever we are generating, like this. Okay, so the same applications we also have them in IoT domain. So I'll show you, like first initially I'll tell you about big data. Then I will discuss about the connectivity between IoT and big data. So let us quickly move to the basic characteristics. So big data, initially people were mentioning about 3 V's, 4 V's, 5 V's. Now actually we are having more than 6 V's, but I thought, so these 6 different characteristics are sufficient for one to understand about big data. The first one we have discussed a lot of time, that is volume. The huge collection of volume is obviously the first characteristic. The second characteristic is variety. So you will not have just one type of data, you will have different types of data. So we will see that. Some participant also mentioned about different types. So it can be structured, semi-structured. That is, you can't expect everything to be like in database tables, or you can't expect everything to be in one specific format. You may have documents, you may have video, you may have images. So you can have any type of data, but still you have to handle it, you have to manage it, you have to extract it according to the user specification, and you may have to even make some decisions. All that will be done. Then comes velocity. This is again very, very important. The speed at which big data is generated is increasing abruptly. Okay, so that is what one thing. And I can give you the best example is, like you can see, like we have the social media data or the media data, electronic media data. So if you see the data being generated so quickly, like every minute you may have yettabytes of data or zettabytes of data. So it's being generated and it has to be stored. Okay, and then comes veracity. Veracity means the degree to which a data can be trusted. This is again very, very important. So many number of times we observe this also. Like you see some data or some post in somewhere, and you will not be knowing whether you can trust that information or not. So the trustworthiness of the data should also be there. And when I am storing it in my big data cluster, or I'm having an environment, a distributed file systems, if I'm storing that, I have to ensure that it should have the veracity. So then value. So value, obviously. So until and unless it adds a value to business, so business people may not move towards big data analytics or big data handling. So then comes variability. So variability means obviously the data can be keeping on changing. Like, okay, so it usually can be handled in different way, and it is dynamic. So these are actually the 6 basic characteristics for a data, which we can call it as a big data. So usually when we deal with the basic definition, or when I ask students to think about the definition, so they usually think, because the word big is taken as an adjective, we think about volume. But along with volume, the other 5 features also should be kept in mind when we are dealing with big data. Okay, so this is about big data basic characteristics, the 6 V's. Volume, I'm repeating once again, and I hope all of you know you have to give a test also at the end of the FDP. Okay, so volume, variety, velocity, veracity, value, variability. So these are the 6 basic characteristics of big data. All of them are starting with V's, so we call them as 6 V's of big data. And I want to focus more because the velocity, I may not have any control on it. Veracity comes under security. That is again a big domain, research domain, where you may have to measure the trustworthiness and all. And gaining value, again, that is the role of data scientists, how we are going to incorporate a few techniques into it, and discover knowledge. So that will make a lot of profit for the business organization. Then comes variability. So this also with the advent of or with the intervention of the users, we will have this variability. But I'm going to discuss about variety. So because in IoT we require this. Okay. So variety. So when I'm telling variety, you usually have structured, semi-structured, unstructured. So structured means you can think it as you mention the format and you usually have them in the table format. Semi-structured, you may not have a complete structure. A part of the data is structured and the remaining is completely unstructured. We can also have completely unstructured data. That means you can have free-flowing text sort of a thing, which you may have in any text documents. Or sometimes I'm having text, I'm having image, I'm having files like this, the presentation. You can have anything. All of them I may consider it as unstructured because I cannot expect all the files to have a fixed format for me. So here when you see, so SQL was very much comfortable, and till today a lot of people use structured data in the format of SQL, that is databases, relational databases. And then when we started using unstructured or semi-structured, like so people wanted to go with new query language. So they actually named it as NoSQL. NoSQL means it's not absence of SQL. It is not only SQL. It's not only SQL. Along with SQL, it will also have features. It will also have the facility to handle some other formats in the form of objects. So usually we call them as blobs or we call them as digital objects. So you will store them. And in the market right now, we have lot of NoSQL databases available. So among them, I have listed only few. Okay. So you can just, if you have time, you can just spend some 10 minutes and can just see one of these and you will know how exactly it has. It again almost it has its base from SQL. It will have commands. It will have some data types. You can store different things. So MongoDB is considered to be one famous tool for NoSQL, and along with that, we also have Cassandra. But here I have also given you CouchDB, which is widely used in some IoT projects. So I'll tell you. Then we have Redis, RavenDB. These are the things we have for NoSQL. And Hadoop technology is quite famous for handling big data. And in Hadoop ecosystem or in environment, we have HBase. HBase is again a sort of a database which can handle SQL along with NoSQL. Okay. So then we also have Hive. So Hive is again a part of Hadoop ecosystem. Hive usually focuses on structured data, handling structured data. Then we again have Pig. Pig is also one of the tools we have in Hadoop ecosystem, which can handle semi-structured data as well. It handles structured and it also handles semi-structured. And Pig is widely called as an ETL tool for big data. So ETL is widely known and people might be knowing, like whoever interacts with data warehouse, they will be knowing. It is extraction, transformation, and loading. Because when we pick data for big data, you are not having a single source. Okay, you have to, because it's variety, you have to collect from different sources. And when you are collecting from different sources, we will extract the data from different sources. When I'm collecting data from database, the method is different. When I'm collecting from XML databases, it's different. When I'm collecting from ASCII files, it's different. Like I will extract accordingly, and I have to decide my target format, and I have to transform it into my target format and then load it into my target place. It can be a table, or it can be a file, or it can be a data store. Okay, so all that Pig has the facilities, or Pig has the command which can handle. So when we speak about big data, we speak about variety. So for variety, you require structure, semi-structure, unstructured. So a document oriented, many number of times we go with XML databases because XML has parsers which will handle the documents in the form of object models. Like we call them as DOM, so document object model. It constructs in the tree format and it has a very efficient query structures, and we usually call them as XPath queries. So all such things are also there for unstructured. So this is how we have a different variation to handle the data. When you deal with IoT also, we again see we may collect data from different devices or different sensors or different, sometimes the contribution of human beings as well. So when you deal it in this way, that you may get in a structured format or semi-structured, or you may have to process them using the big data technologies. Okay, so this is about variety. And we have just seen big data, the characteristics of big data. So what is the use of big data? Just now, as I mentioned, we have to show that the big data processing should add value to the business. So if it is not adding the value, we don't want to use big data. So how do we add value to it? So people have used a lot of statistical methods for analysis. So in analysis, you just understand the data. But when we dig deep, and you are making some decisions, or you are giving some important knowledge to the users for their processing. So we can do analytics. Okay. So analysis, when you do in a more advanced way, you can call it as analytics. So big data analytics exclusively focuses on helping the managers or helping the customers in making the decisions. So keeping this, the big data analytics have gained lot of significance because we have lot of data and you want to perform analytics on it. So usually we teach students about data mining. So in data mining, what we usually teach focus only on knowledge discovery. When a given data, how I perform clustering, how I perform classification. Similar things we also do in analytics. Okay. So here I'm going to give you the 4 different types of analytics. And I want you people to just remember, we usually do many number of times in our real world also, we usually do these kinds of analytics. But many number of times we just do descriptive analytics. Very rarely we do diagnostic analytics. And we are not that comfortable, or we are not perfect in doing predictions. And very few people will have the ability of prescriptive analytics. Okay. So descriptive analytics means you have some data like history data and you just understand what happened. Okay. So now you see, today actually I was going through the news that we had some situation in a place in Andhra where a lot of people were having some kind of problem, health issue. And we were shown what has happened. From yesterday they're showing. So today they have identified the region and they actually mentioned, so there is that particular problem is due to lead. So that is, they actually mentioned why it happened. Okay, that is diagnostic. So something has happened and you want to dig deep into the reason why it has happened. If I'm just covering, I'm focusing only what happened. The diagnostic I have to dig deep into and I have to do why it has happened. Predictive means based on the current data, I have to imagine the future, or I have to predict the future. So what will happen? So predictive analytics are again very much required in almost all that domain, whatever we are doing. And I can give you one simple example. The predictive people usually we are having lot of applications or lot of projects where people want to see about the cancer detection. Like they may guess, like you, because of these kind of your parameters, so you are prone to get this disease, or it can be cancer or it can be diabetes. So they usually tell. So if you are doing this sort of medical parameters, so you maybe after 10 years you may get arthritis, or you may get. So that is predictive analytics. So usually now doctors will usually mention this, that we want our programs to do that. And predictive analytics, I think you might have seen. So prediction means always we know from our childhood, we know it is weather prediction. So people usually tell, okay, meteorology department will give you the prediction. So similar to that, everywhere they want prediction. So they like share market. You want to know which company share will have value in coming 15 days or in coming 1 month. So there again, people want predictive analytics. Okay, so like this, we have a lot of requirement. People want predictive analytics. And next we have prescriptive analytics. So this is again very much people get fascinated by this. That is, it is a kind of recommendation system. Okay, so is anybody experiencing this results like a prescriptive analytic program outcomes you are experiencing in your real time? Do you know somebody is already working on it, or they are very good in prescriptive analytics? No, nobody. So, how many of you have Facebook? I have almost all of you. Yes, almost all of you have Facebook. So in Facebook, will it give you people whom you know? They'll give you people you may know. That is friend suggestions they give. And when you are spending, going through some videos, so next time when you switch on, so you will be shown the videos which you have a previous day you have viewed. That is, it is picking, it is having lot of videos, but it will show you the more recommended, like it recommends you the suitable videos what you have already seen. So based on your previous browse history, it projects the recommendations. Okay. So similarly, you go to Amazon, like e-commerce app, there also. So it displays you the products which you have already purchased or which you have already browsed. So like this, customers need to be delighted. For that, many organizations or many applications are going for this prescriptive analytics, that is recommendations. Okay. So we can have lot of research scope in this prescriptive analytics. So now let us consider, I'm reading news about some particular segment. Let us consider, I'm interested to know about news about the achievements what the NITs are doing, or let us consider the achievements what IIT Hyderabad is doing. I'm just interested in that news. So when I'm reading that kind of a news, whenever something happens in IIT Hyderabad, I should be shown that news. That means I don't want to go through the total newspaper. I just want to have that sort of recommendation. Like the system should know what I'm interested in, and it should project me only the news what I'm interested. Okay, like we have like this news apps also, short news apps. So this is about prescriptive analytics. So descriptive, diagnostic, predictive, and prescriptive. These are 4 types of data analytics. Okay. So as a teacher, some of your research scholars, some of your teachers, I guess. So as a teacher, which kind of analytics we want when we want to handle our students? This is a question I won't answer because this is almost reaching to lunch time. I want you people to be connected to me.
Can you repeat the question, ma'am?
As a teacher, so we are having data about our students. We are interacting with students. We have verbal, non-verbal, lot of type of communication. What kind of analytics we do much? We apply much for students.
Diagnostic, we can apply for the 3 kinds, ma'am. The diagnostic also is most way. Actually, suppose if the student is failed, then we have to why it happened. Actually,
Yes.
he is a good student, and we will apply diagnostic analytic. After
Yes.
that, is any certain cause is there that moment actually, so he is not perform well. Diagnostic analytic we will perform, and later if the student is asking, ma'am, you have seen and you can recommend me to go for the next which field I can choose and move towards that.
So
So
many number of times we will be doing diagnostic, and when they come to us, then we do prescriptive. Okay,
Yes.
so when they don't approach us, we usually, like if they are proactive, then we do prescriptive. Otherwise, we do diagnostic. And somebody has given me in the chat like to identify weak or good students. That is, we can do descriptive also. Okay, descriptive analytics we do, and we do. So in everyday life also we will be doing this, but now we want our programs to do this. Okay. Okay. Thank you for the answer. And now we will quickly move on to, so till this slide, I want to just give you information about big data and big data analytics. So now we will quickly move on to IoT. And IoT, have already seen one day, and you pretty well know about IoT. I don't want to spend much time. I just want to mention that the number of devices present in connected to our internet are increasing rapidly. And actually, by surveys, people have mentioned around 5,000 crore devices will be connected to internet. But now it's increasing a lot. Okay, so now almost I can tell 50% of the houses have this Alexa, or 50% of the houses may have Google Assistant, and almost the bulbs, everything. They want a smart home. Like this, the number of devices keep on increasing, and we can just tell it is Internet of everything. It's not only things; it is everything is connected. And then I think you have one more session on cyber physical systems, and even the research funding institutions are very eager to fund you if you are doing some research on this cyber physical systems. Okay, so that is cyber physical systems integrate sensing, computations, control, and networking into physical objects and infrastructures. And these things, the physical objects may connect to each other, and they also will connect to internet. Like you will have a data center, and that it
Ma'am,
can tell me.
ma'am, sorry to interrupt.
Hmm.
Screen is not visible, ma'am.
It's not visible.
Yeah, and I mean PPT is not visible.
What happened? I did not ask anything. Okay,
Yeah,
I'll
yes,
just
ma'am. Yes, ma'am. We are not able to see PPT.
okay. Is it visible now?
No, ma'am. No.
No, ma'am.
So I'll stop sharing it, and then again I'll share it. One second.
Yeah, okay, ma'am.
Now is it visible?
Yeah, it is visible, ma'am.
Okay.
Yeah,
So
thank you,
in
ma'am.
okay. So we are having the cyber physical systems, and a lot of organizations also want new research components or innovative things in the cyber physical systems as well. So we will see, like Internet of Things has gained a lot of significance, and now everybody wants smart devices, smart applications. So everything we want automation. So we don't want a human to get strained. And when you have this sort of a thing, and you can see when our students get excited when they do this kind of experimentation. And I have seen lot of UG students participate in hackathons, and they usually do lot of new innovation. Like I was very much fascinated to see they have this remote control of a rice cooker. So like this, whatever the device we have now, they want it in automation. So in such way, we have a lot of physical objects. You may have infrastructure, and you want to connect the physical objects, and you want to see there is some collaboration and networking, and with that you want computation. Okay, like this, actually, a lot of research is happening in IoT. So we will see how IoT meets big data. So here you can see Internet of Things. So you have lot of different devices, like you can have industries, systems, human beings, smart devices, and anytime any context, and like this, the location, GPS data, everything. And all these things are again generates lot of data, and that can lead to big data. And whatever we have in big data applications, like whatever analytics you have, so those the outcome of the analytics can be used to improve your capabilities like IoT. Okay. I hope some of you might have known about this smart refrigerator. Anybody know about that?
Yes.
Smart refrigerator?
Yes, ma'am.
So what do you know about smart refrigerator? What is smartness in it?
Smart in the sense of like they have issued some app actually. Suppose if you
Okay.
take LG freeze refrigerator, they have issued some app, and we can able to control the temperatures.
Yes.
Suppose freezer temperature. If I kept it something ice cream and all those things, I can able to increase or reduce the temperatures of the freeze according to what items are there inside there.
Yes.
And one
Yes.
more thing, if suppose the refrigerator is getting damaged actually, so we have to keep that mobile, the smart device in front of that eye, and so that actually it will be visible where that problem is occurred actually in the entire of the whether cooling compressor is not working.
You are giving about temperature control or setting the temperature according to the objects. There you could see smartness. And if something damage happens within the fridge, so it will give you information and accordingly you can reflect. Yes?
Diagnostic.
Yes,
Diagnostic.
that is diagnostic. But a very important thing, what I liked or what I got excited is the fridge will be fitted with a device, so which will get trained. Like it will have a machine learning program. It gets trained, and it knows what kind of vegetables or what kind of fruits we eat in our home. And whenever the objects are missing in the fridge, it sends an alarm message or it orders in Amazon. So Amazon, it gets connected to Amazon app and it places order and you get delivery. Have you ever come across that? No, you did not.
That feature is there, but we didn't come across of that.
No, that's what I'm telling. Right now, it is not available in the market.
Yes.
So it's still the research is going on. Like when you look it in this way, so that means we need not even know remember what I want for next day. So the smartness or the automation will happen even for the refrigerator in such a way that so it reduces my burden. Like tomorrow morning, if I want to cook, just whatever is required, it will be readily available there. They will be either in the fridge or at my doorstep. So this kind of comfort we actually want. Actually, you might have seen we have these funny videos about smart home appliances. Somebody will never touch anything, any physical object, and the physical object keeps on responding to our voice commands. And what happens if my voice gets changed or if some surgery happens to my teeth? So we actually have this sort of a thing. So this actually, the big data, that is the data will be processed. Like it every day it sees what are the vegetables which are kept for 1 week. Then it has to train itself and then it has to detect what is missing and it has to place the order. Like this, we have smartness in all, and I definitely require that. I want to see, that is, I want to sense, or I want some image processing capability. So to know what vegetables are regularly there and what vegetables are not there today. So like this, we have, these are simple home appliances I'm giving, and this sort of things will be there in lot of applications. So just here, the takeaway point is data is integral to IoT. So IoT generates, like Internet of Things, Internet of Everything, generates lot of data. So here again you can see we have lot of common IoT standards and frameworks. Again, the different domains we are having. So healthcare, home and building, that is safe homes, we can tell. Retail, energy, manufacturing, mobility transportation system. Again, we have lot of research happening even in this transportation, smart transportation. Logistics, this is about shipping or the courier services and all. Then we have media, then health. So these are all the different domains where the data is being there, and you can just see you will have lot of stakeholders or lot of end users who are actually interacting with it. So you may have manufacturing industries, automation equipment providers, so like this. And energy is one thing. I don't know whether that was discussed in your previous class or not. So right now, a lot of governments are moving towards this smart grid. So that is energy grid. They want to make it a smart grid. And again, we, the computer scientists, have to assist electrical engineers in improving or making their systems automated or smart. Okay. So here data is integral to IoT. So when the data keeps on increasing, you should definitely know what kind of handling we are doing and how we are dealing different data processing things. So here in all IoT domains, data is mandatory. So these are all the different activities one has to do. First thing is you should know how to collect data, like from where you are collecting the data, what sources you are picking and you are doing. And afterwards, you have to monitor the data. Many number of times you may have noise or you may have irrelevant data, you may have redundant data. So you may have to filter out all of them. And then you may have to share it to other applications. And when you are sharing for other applications, so those applications may pick up the automation process. And for that, they actually require controlling of data and collaboration among all the devices. So these are all actually considered to be the basic things what we are doing in IoT domain. So here in big data also, if you see, we have seen, so you can collect, you can process. So here I'll just show you. So this is actually the thing. Okay, these are different levels. I hope the font size is small. Just I want you to be more careful. So here, the first level, we are having the things in IoE, that is Internet of Everything. You will have the physical devices and controllers. So that is, you can have your sensors, the cameras, like whatever you have, edge nodes, all intelligent edge nodes you will have. From that, you may have actually go for communication. You will connect them and you will have the collaboration. Then we go for edge computing. Like you may have to pick up the data, you do data element analysis and you do transportation. Then comes the storage, like how you store, how you accumulate the data. So this data accumulation can be considered as data collection, which in turn has, you need to have knowledge about all these three layers. Once you have storage, then you go for data abstraction. That is, you don't deal with detailed data. So when we go for knowledge or when we go for analytics, so we want summarized data. So for that, we are going for aggregations and then it will be accessed. So then the sixth level, we are having applications. Like you can have just reports or analytics, or you can also even control the data. Like let us consider we are not getting from one sensor. You are not getting from one location. Like you may have to check and you may have to control. So then at the end, we'll have people and business processes. So here you usually help them. It is like almost your user level interaction. So it should make sense for them. So this is what we are considering it as the business center. Okay. These are all the different levels where we interact with data in IoT. And obviously the size keeps on increasing. So what kind of big data approaches we do? So I'm not focusing only on analytics. I am also mentioning what are the different things. Storage is very essential. So how you store, where you store is again essential. So if you see simple IoT applications, what usually UG students do, so they usually do it with Raspberry Pi or Arduino board. So that particular storage is sufficient, you can store that. But when you are dealing with lots of sensors and you are having a stream of data which you have to collect and store, then usually we go for clouds, okay, cloud storage. And along with that, if I don't want to store in a private cloud or somebody's cloud, I want to store in my own server, then I usually go for Hadoop setup. There I can go for HBase and Hive. Like Hadoop, we also have Spark SQL. As I already mentioned, MongoDB, MySQL. And if I'm having structured data, you can also have centralized databases. Like you can have a simple RDBMS. Then once the data is there with us, so before applying analytics, I may have to go for cleaning. So cleaning, as I mentioned, we have integration, aggregation, and along with that transformation. And sometimes we can also go for anomaly detection. So like let us consider, I know the temperature sensor should send me the data in Celsius, and I know room temperature or a building temperature will never exceed, let us consider 37 degrees Celsius or 40 degrees Celsius. So if at all by mistake I get 147, I should identify it as an outlier. So such things should also be there. Like we also require algorithms to do that. And then we also go with logical inferences and entity linking. So these are all the things we do. Then comes analytics. So in analytics, as I just shown, like we have 4 different types of analytics. So predictive analytics, I focus more because that's where people are interested. So in predictive analytics, a lot of researchers are focusing there. So it is in this way, like I take the current data, I take the history data, and I write a machine learning program or a deep learning program, and my program builds a model. It trains itself to the previous data, and it has to suggest me what should be given for the next case. That is, when a new sample comes, it should give classification. So a lot of times classifications happen. And in classification, you can go with fuzzy neural networks and all that. Then we can also go with grouping sort of a thing, that is we do in clustering, and map reduce framework exclusively to address a specific requirement in analytics. And ARM stands for association rule mining. So these are all the techniques we study in machine learning and data mining. And one more important thing is semantic mining. So semantic mining means, so we are mining not only the data, but we have to understand the user's interest behind the request. So that is the meaning against the requirement, or what is the intention of the user. If you are able to observe and then accordingly, if you are discovering the knowledge, so we call it as semantic mining. So again, we are having lot of research happening. This is where you can think a machine as a smart if it is doing semantic mining. So then at the end, you have to display the results. So like in the previous slide, we have seen the top level, the business processors. So there you should impress them that whatever the result you are giving out, it should not be just a table format. So we should know about visualization, how effectively you display the knowledge. So for that, we actually have different visualization techniques. So that is, it should be used to interpret the knowledge. It should be very easy for the users to interpret it. Then we also go for visual experiment. So again, lot of innovative methods people are identifying, and they want to see how effectively you can visualize the results. Okay, these are all the big data approaches we have in different IoT domains. So just I want to tell you, like if you are dealing with IoT domains, so you should have a knowledge about these things, how you store. Among them, majority number of times we are having this big data technologies. Okay, so then cleaning, we again deal with pre-processing. We call it as data pre-processing. So we want to see the data quality should be increased. In order to increase the data quality, we again take lot of measures and we apply the pre-processing. Then we apply analytics. Analytics will again have a combination of different algorithms. Then comes visualization. Okay, so this is what I want to tell you. Just now I have taken only 4 domains, and I want to just show you what kind of research is expected, or what kind of challenges people usually have, or benefits of data analytics. So what kind of benefits we can give in using IoT data. So smart transportation system, like transportation, as just now I mentioned, so we should be able to reduce accidents. Like you do analytics, like many number of times we do diagnostic analytics, and we again give the prescriptive analytics. Like we suggest people few things, and thereby we may reduce the accidents. Then the second thing, the benefit will be you can minimize the congestion. Okay, so you might have seen this minimizing the congestion. Many number of times we use this Google Maps. It suggests us the path. Okay, so it suggests us the path. This is 5 minutes slower. This is 10 minutes slower. Like that, it mentions. So can anybody tell me how exactly it's doing it? Is Google Map helping us avoiding the traffic congestion?
Actually, they are using the number of mobiles which are on the road right now. But so many people have on their location option in the mobile. So they
Right.
track the mobiles, and then according to that, the number of mobile on the road, according to that, they tell that how many people are on the road, and according to that, they predict that which where is the heavy traffic or not.
Okay. So many number of times it so happen. It may not, like sometimes it may be misleading also because the mobile usage. So sometimes it so happen one person may have four different mobiles. And let us consider you have a lot of people going in two-wheeler and they may not have mobiles at all. So usually they have identified it and given. But what we want is, so you can have, like you have the surveillance cameras. So with this, you may have to identify the vehicle movement and then it has to give. And again, here, the third one is optimizing shipment movements. So it suggests you the path. Like if I mention the source and destination, it suggests you the path. And that suggestion also may sometimes if you are like moving within the city or if you are moving within same locations, it may be better. But if I choose a source and destination which is quite far away, so it's not giving actually the optimal. So why I'm mentioning this is so that we require a lot of research. You have to identify the exact methods how I can optimize the shipment movement. I can the suggestion, the best way suggestion or best route suggestion should be given, not just what is happening now. Right now, what is happening, we are okay, but in all cases, it's failing. So that is again we want. How do we optimize the shipment movements? So there again, we may require some information from satellite, or we also want dynamic data. Sometimes it so happen it suggests you a movement, and suddenly there is an accident there. So that it is not updating dynamically. So like this we have. Then we also have ensure road safety. Okay. So these are all the different benefits what data analytics can give when I'm applying for transportation IoT. Okay. So then the next thing is healthcare. And I think healthcare, we have a lot of research in healthcare IoT. So here again, we are having predicting epidemics. So here again, predictive analytics plays a very important role. And like I think 5 years back, I was very much impressed the way people have done prediction of flu using Facebook data. So that is in Facebook, they post something. The people usually post, and just by gathering that particular data, they usually have predicted the flu outbreak. And they have also identified what is the geographical location, how it moves from one country to other country. So like this, we actually have the big data, people do predictions, and even in healthcare IoT also, we can predict the epidemic diseases and cure. And the second one important is help insurance companies make better policies. So you do diagnostic analytics that, and then you may suggest the insurance companies. Okay, that can be done. And the next is just now as I mentioned. So serious illnesses, if you can detect the early stages, you may usually get fast recovery. So this is very much applicable. Like if you could detect cancer in the initial stage or first stage, you can easily come out of it. So this is again we want IoT. Like you usually pick the data at regular intervals of time. Okay, so all now I could see more than 50% people or young people will be having this fitness trackers. So from that, so you may have in such a way you can again have some wearable devices from which you can detect, your program can suggest them what care they have to take in order to avoid the diseases. Okay, so then comes smart grid. This is again, as just now I have to mention, lot of governments are spending or they want the smart grid technologies. So why, what kind of analytics we can do is, the analytics, what we do, can design an optimal pricing plan. So that you can come under descriptive analytics, like what is the previous usage, the previous 5 months usage or 1 year usage of all the people or all the industries. And then you can also come up with optimal pricing plan. Then you can also go with predict future supply needs. This is again a very, very important. Like usually we see in winter there is less need, whereas when it starts summer, the future need will increase. So how you should see and how you should generate the power and how you should preserve all that, again they need some support from big data analytics. Then appropriate level of electricity supply. This is again comes for distribution, how efficiently you distribute. Okay, so this is about the smart grid domain, and some of our professors are also working on this. A lot of research is happening in smart grid using IoT, and they are able to get patents also by incorporating this analytics and IoT concepts into their machines. Okay. So then comes smart inventory system, and this is usually we are very much experienced with this, exclusively with this pandemic lockdown period. So we are using, like you are actually placing lot of orders on inventory system. So when you have your Amazon app or Go for app, you will have lot of apps. So you should see, like that is the administrator should detect the fraudulent cases. Similarly, it should identify the fraudulent vendors also. So then they also will have analytics will help them in placing an advertisements in a suitable location. And they have analytics to understand customer needs. That comes under predictive analytics. So there again, we again have a sort of association rule mining. So if somebody purchases an item now, so what item they may purchase next week, or what item they may purchase within 1 month, or what item you may promote them for next 1 month. So like this, we usually have the customer needs. So then actually, how to identify potential risks. So this usually can be considered as an anomaly detection. So which again a part of big data analytics. Okay, these are the 4 domains I thought I will discuss, and I'll also discuss what are the opportunities IoT is giving for big data analytics. Okay, so when we deal with IoT, what opportunities IoT gives. So you can just see mining IoT data, like whatever we collect. So it definitely will improve the decision making habits of individuals using big data. So the decision making can be improved with the help of big data analytics. And along with that, the second opportunity is we can improve the efficiency. So that is, you have current big data technologies which will build around low cost community hardware using IoT, and which will definitely improve analytics capability and reduce processors cost or processing cost. That again you can again think about how you can improve the efficiency. So then we have independence from data silos. So this is again one important thing we have in big data. So data silo is a situation wherein only one group can access a set of data. So you may not have like from different domains, data cannot be accessed. So, but when I have this IoT, so I want independence from such kind of restrictions. So data should be shared, because we have seen sharing and automation are very much required in IoT. So that kind of thing can be achieved. So that is, independence from data silos can be achieved. So then obviously we want value added applications. So that is, we use all other technologies such as deep learning, machine learning, artificial intelligence. So when we use all of them, you can definitely combine IoT using IoT and big data. And one more thing is, we also have different business intelligence platforms also, where they want the smart decision making programs. So all such things can be done by integrating IoT with big data. Okay. So then we also have the open challenges or open research challenges. Okay, so we actually have lot of research challenges with respect to big data based on IoT. So exploit usefulness of IoT. This is again very much required. Like you are taking the census data, so definitely the order in which you collect or the time series based or the stream based data is very much required. So how do you exploit the temporal usefulness? That is again a research challenge. Then, as I mentioned, how do you add semantics to IoT data? This is again a very big challenge, and we want a lot of cognitive science researchers help we want in adding semantics to IoT data. Okay, this is in this way. How human brain thinks, we will understand the user request or user requirement, but how our program needs it. So there, that is again one big research challenge we have. Then we have this diversity issues. So diversity issues, as we have seen, the data comes from different places, and different applications follow different protocols, and you may have different standards. All of them, you have this heterogeneity as a big problem. How to fix them? The integration should become quite easy. It should not take a lot of time and effort. So that is again, we have some research challenges. Then comes security. As you know, security is again a very big domain. We have lots of challenges like internet-based security, network security, so data security. So how you provide this kind of security, and how do you provide or measure the trustworthiness of the data? That is again a big issue. So then comes data management. So when you go for data management, so we may store data in one particular location that is structured or unstructured, and how usually you will forward this or you will process this, and how you are going to share it with others. So we have such kind of things in data management issuance. And then comes data provenance. So provenance is linked to authenticity and integrity of the data. So this again can be considered as a sort of how do I check whether the data is having integrity or not. It also can be considered as the things. And along with that, you can also think about how do we keep privacy of the data. So you may use big data for analytics, but still you should preserve the privacy of the data. So then actually we have the last challenge, research challenge, that is data governance and regulation. So this is again we have, so this is one important aspect. How do you govern the data? How the data owners must be given more power to allow them to make decisions within the scope of overall policy framework. So here again, these things you can think about your cloud infrastructure. Like if you are storing the data in the cloud, whatever the challenges you have. Similarly, for IoT data also, you will have this governance and regulations. Like we may have third-party authenticity, or you may have third-party which will regulate the data usage, all that. So here again, we'll have auditing concepts, everything. So these are all the open research challenges we have when I'm dealing with IoT data, which is obviously over a period of time, it has to be handled using big data technologies. Okay, so this is about the opportunities in IoT big data and open research challenges we have here. And that's all from my side. And these are few references, the big data textbooks and few research papers I have giving for references. Big data for IoT survey. This is considered to be a good paper. And this is also published in 2017. So this is also giving a lot of information about the big data and IoT integration. Okay. So that's all from my side. If you have anything to be discussed, I'm open. Any questions from the participants?
Ma'am,
Tell me.
can I ask?
Yes, please.
Ma'am, here you are saying that suppose some data actually, suppose if you take it of university application, sometimes
Okay.
we can allow to share the student data and just address, and we don't want to reveal of marks. So you are saying that it is possible with the trimming of the data. How actually it can able to, is like any techniques are available to trim such a type of and then share it?
Actually, we have, like when you are storing it in a database, so we have different models to ensure database security. Am I audible to you, Madhavi?
Yes, ma'am.
Yes. So we usually have different models. So when you are having a database, so you usually mention the level of the attribute, whether it is sensitive or not so sensitive. We usually give at a scale of 5 or 6. And based on the level, when somebody is extracting data from your database, it can be you or any admin. So they will be given privileges only up to some level. So if you annotate one attribute as a sensitive, no program will be allowed to read it. So you can keep such kind of checks within your database.
Okay.
The authorizations you can keep.
Yeah, it means that we have to set the property or set the attributes property so that actually
we call it as security levels.
Okay.
Okay. But we have lots of problems also here. So you could see, especially healthcare data, it's considered to be quite sensitive. But so you trim some attributes, but still people can do the statistical inference. You may clip the name. Okay. You may click the address of the patient. Okay. But still, based on other attributes, they will be doing lot of inference dragging mechanism, and then they will be filling the missing data. So we have such kind of hacking also. So still a lot of research is required. How you give privacy to the data. Privacy preserving is a big challenge in big data.
Okay. Any type of such algorithms are there, ma'am, to extract and to provide till now, actually, because still research is going on. Still now, can you able to mention of the algorithm or technique?
No, actually, we don't have any such algorithms which will filter out the sensitive data. So actually, we have some models. So that is, your database has to adopt that security model. So we have such security models which can preserve our data.
Okay. 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 Thank you, ma'am.
Okay. Any more doubts? I think it's almost 1:50. You may have your lunch break. Kavita, madam?
Ma'am, thank you. Yeah, thank you, ma'am, for your stimulating effort. We appreciate your approach to anticipate research intent. Your enthusiasm is contagious, and we hope to use your thought process. Thank you again for enormous contribution in today's program, ma'am.
Okay, Namrata, thank you. And thank you for
thank you.
Madhavi Devi for giving me a live experience. Like until and unless somebody talks, we are not getting the zeal to continue the discussion. So I thank all the participants who have participated and who have actively interacted with me. Okay, thank you. Thank you for giving me this opportunity, the organizers. Thank you. Bye.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am. All the participants, you have a lunch break till 2 o'clock. We'll start the session at 2 o'clock. Third session.